In this video, I will upgrade the supercapacitor bank from 6S to 7S and test it with my pure sine inverter running directly off of solar panels. What is shown here is two banks of capacitors taped together. You've probably seen these boards available on different online sites. 6 capacitors is not enough for my application. 12 capacitors is too many. I was not able to find this particular capacitor available. I could find other types, but I couldn't find this exact type. What I really want is 7 or 8 capacitors in series, and I can't find anything that meets that requirement. So what I decided to do is just tape them together, and I'm going to wire in 1 or 2 additional capacitors as needed, and the rest will just sit there. They won't be used. I could still use them for something else and wire them in separately, but right now I'm just going to come from all the way along here and then jump to this capacitor, and I may add this one in later. The capacitors will not balance themselves. They are very different from one another, and they're always out of balance, so you need some kind of circuit that will balance them. I have seen these boards all over the place. They have a little balancing circuit, and you can see little resistors on there and little chips that will turn on the balancing resistors. But unfortunately, these boards, in my experience, they don't work at all. They just don't work, and I really don't want something that I have to babysit. I want something I can leave unattended. I want guaranteed balancing. So the type of balancing I've been using is this flying capacitors so-called balancing board. This is an active balancer, and an active balancer takes current from the high cell and shunts it into the lower cells. I have discovered that this type of balancer works extremely well. It is very, very impressive. It may seem kind of odd to balance capacitors with capacitors, but it's very effective, and these circuits are a little pricey, to be honest, but they work so good, I'm willing to pay it. In one case, I attached this balancer to this supercapacitor bank. It had approximately 900 millivolts, or actually it reached a volt in differential between the cells. And this balancer tore that down to less than half a volt in just a minute or two. It was extremely fast. Of course, this type of balancer, the more differential between the cells, the more balancing current. So the effect slows down. Once it gets up to about 200 or 100 millivolts of balance, it's slower, but it still works very, very well. I will attach some footage here showing the balancer in operation earlier, and I'm using a balancing computer, not the balancing function, but just the cell monitoring function, to show what the cells are doing, or capacitors. And you can see how quickly they were balancing. What I did not show was where it was all the way up to a volt, and it was balancing them so quickly, I was amazed. I actually didn't get to record that on camera. I hope I get another chance. This is the balance header that comes with this balancing board. It's pretty heavy duty. The wires are nice and thick. Unfortunately, this is a 7S balancer. I thought 7 capacitors would be enough. Apparently, I may need 8 in some circumstances. To monitor the supercapacitors, I use this Battery Go or ISDT BG-8S battery computer. It also has a balancing function. This supercapacitor is to be charged by a single 100-watt solar panel, and it will also power a pure sine wave inverter. This will be used to run various appliances directly off a solar panel. I have a separate video, which either is going to be uploaded or is already uploaded, that covers this project. Alright, I'm going to go ahead and connect the balancing computer here and just see what the status is on these cells, or capacitors. I keep calling them cells. I guess they could be called cells. And it's been sitting overnight. I'm just curious to see. And actually not bad. These capacitors are holding their balance pretty well. 153 millivolts without any balancing. I need to order a 7S or 8S balance lead to run this balancing computer on. And that way I'll be able to monitor the additional 1 or 2 capacitors I'm going to add. For right now, I'm just going to wire in the additional capacitor, and I can monitor them separately using a multimeter. This is all very messy and confusing, so let me just explain what I have. This is the first supercapacitor bank that's taped to a newer one that I have. All these wires here are just balance headers, and I have 2 balance headers, so that means double the wires. This is the balance header I use for my balancing computer, and I really just use it to monitor the cells. I don't use the balancing function on it. Then you have these bigger wires. These go to the active balancer. I have one additional wire, which is the red wire, and that's going to come around and go to this terminal here. This is an extra capacitor, so it'll be 7 capacitors in series, and I won't be connecting to these at the moment. I will need one wire going from the positive of this supercapacitor bank coming around here to the negative, so that'll need to be soldered there. I do have a fuse temporarily installed just to keep things safe. So first I need to connect the yellow wire here to pull in this additional supercapacitor and give me a 7S supercapacitor bank. So I'll just heat up the soldering iron and get that started. And I'm just tinning the wire a little bit to make it easier to attach. See if I can do this without heating the capacitor up too much. And I don't know if that took or not. Okay, it's not the best solder joint in the world, but I don't have a lot of time, so I'm just going to go ahead and leave it there. I pulled on the wire and it didn't come off. Now I need to make an attachment to the positive side of this capacitor right here. And the way I'm going to do that is simply a terminal, spade terminal. I have a lot of them laying around and I'm not using them. I need something to attach alligator clips to while I'm doing testing. I've attached the spade connector on there temporarily just so I have something to put my alligator clips on and attach wires. Now I need to attach this red wire, which is the most positive part of the active balancer. Alright, got that on there. I'm not sure exactly how I will have this capacitor being wired up in the end, but I need to get it up and running so I can test it. I have built a wooden enclosure for this project, but I haven't really started using it yet. Right now I just want to wire it up and see what happens. 6 capacitors was completely inadequate. I'm hoping that 7 will be enough. Really I need 8, but 7 will be better than nothing right now. This has now become a 7S capacitor bank. It's these 6 here, and I added this capacitor in here. Later I may add this one in, but right now I can only do this one. This one here probably doesn't have much of a charge in it, or it may have no charge. So I'm going to go ahead and attach a multimeter, and we'll see what's in it. Just clip this on here. See what's in here. And I'm getting absolutely nothing. So this capacitor here needs to have a little charge placed in it. I don't want to risk reversing this capacitor when I put it in circuit with the others. In order to charge this capacitor I've added, that would be number 7, I need to use a small power supply. So I'm going to use this little bench power supply I have here, and I'm going to connect it to my solar panels. On the end of this 2.1 millimeter plug is a 200 watt solar panel array, which I've shown in other videos. It also powers a lot of other electronics. And I'm going to set it to 2.6 volts. I don't know what the current is. So positive, negative, let's go ahead and charge it. And I'm putting 1 amp into it. And it's 0.6 volts. Alright, 0.7 volts. So I have jump started this capacitor. Now what I need to do is attach my active balancer, which connects to here, and give this a test. This is the first time I've run it with 7 cells. I also have this battery computer here, but I can only monitor 6 of the cells, the first 6, because I don't have a 7S balance header yet. I will be ordering some, but I wasn't sure if I was going to do 7 or 8 cells, so that's why I hesitated. I now have 1.4 volts on that extra capacitor I added, and you can see the other 6 cells are about 1.8, 1.9 volts. So now I'm going to turn off my power supply, or disconnect it, and turn on the active balancer. The power supply is turned off, but it's acting like a voltmeter and showing me the voltage of the cell. The other 6 cells are monitored here. The capacitor bank currently has 169 millivolts of differential, not counting the differential in this cell, which is much higher. I'm going to attach the balance board now. But there is no activation light on the bottom of the board, and that's because this board requires at least a half a volt or 500 millivolts before it will start operating. Over here on the left hand side you can see an alligator clip. This has a 100 watt solar panel attached to it. I also have a yellow alligator clip, which is right here, and this has the positive side of that 100 watt panel on it. So what I'll need to do is attach it to this point right here, which is the 7th capacitor. Attaching the solar panel will start charging the capacitors and hopefully activate the balance board. I'm now going to attach the solar panel, and the voltage is going up really quick, and hopefully the balance board will activate. And I just heard it turn on. You can see that yellow light right here, and you can see the battery monitor is showing 100 millivolts now, dropping down. It's actually going all over the place. And it's actually more than 100 millivolts because this capacitor here, which is not being monitored here, is way out of balance. And now it's down to 80 millivolts for the first 6 cells. Now I'm going to disconnect the solar panels, and that will allow this capacitor bank to start balancing using the active balancer. It's now down to 60 millivolts, and you can see how quickly this flying capacitor's balancing board works. It's very, very fast. I'm very impressed with these boards. I now have 2 of them, and I'll probably never buy the old style active balancer ever again. And it's down to 50 millivolts now. It's very good. And it's already brought this capacitor up to 1.9 volts. It's continuing to balance, and you can see it's now in the 40 millivolt range and still shrinking. The effect is diminished as the differential between each cell reduces. This active balancer puts less and less current into the adjacent cells, but it's still a very good product, and it works much better than the old style balancing boards. Now in the 30 millivolt range. This cell has come up to 1.95 volts, so it's really close to the others now. Now the differential is about 24 millivolts. This one's up to 2 volts, and it's still working very, very well. This balance board is still on. You can see the yellow LED, and you can hear the board when it kicks in. It makes a high-pitched sound because it's in the frequency range that's audible to humans. It really isn't annoying. It's actually nice to hear the sound because you know it's working. And now it's down to about 18 millivolts. Of course, it's slowing down, but that's not really a problem. So this setup here is going to be powering my pure sine inverter directly off a solar panel. And you can see the cells are at 7 millivolts now. The board is still in operation. The yellow light is still on. This cell has a little catching up to do, but it's pretty well balanced. Right now I have 7 capacitors in series, and I cannot go over 2.7 volts per capacitor, so that gives me a maximum of 18.9 volts. 18.9 volts only applies if the capacitors are perfectly balanced, which of course they probably won't be. It looks like I'm headed for an 8 capacitor bank, but 7 will do for now. It will allow me to run my solar panel under load into an inverter and operate my appliances directly off of solar. Next step will be to take this configuration over to the workbench and fire up my inverter and see it run. I have transferred the whole setup over to my other workbench. In a previous video, I showed an earlier version of this setup. I now have an additional capacitor in series, so I have 7, and that should help with the voltage. Originally, the solar panel was pushing the voltage too high, and it was overvolting my capacitors. This is not the 8 capacitor version. I will eventually move to 8, but this should be good enough to do some real testing. I'm going to go ahead and power up the inverter. The inverter is attached using pretty long alligator clips, but I don't think that will matter. The inverter will not start because the voltage of the solar panel open circuit is too high. So what I need to do is attach the supercapacitor and get it charging. So I'm going to go ahead and do that using this alligator clip. That's the solar panel, and I'm just going to attach it to the negative side. That will cause it to start charging. Now we'll power up the inverter, and it powers up fine because the voltage has been pulled down. Now I turn on my air purifier, which you cannot see, it's off the screen. And I've got it on high right now. And despite having it on high and pulling about 24 watts, the voltage on the supercapacitor continues to go up. It's currently at 16 volts, but you can't see the full voltage on this device here because it's only showing 6 of the cells. You have to add that in with it. So it's about 16.5 volts right now. I'm going to try charging a Ryobi power tool battery because that will really work the capacitor hard. I'm currently charging the power tool battery and running the air purifier. I'm drawing about 68 watts on the AC side, as you can see in this meter right here. And currently the voltage is starting to fall. You can see on this meter 6 of the cells adding up to 15 volts is starting to fall. I'll turn the air purifier down to medium, and let's see if that makes any difference. Still falling slowly. Let's try turning it down to low. I'm now drawing about 50 watts, well 56 watts on the AC side. But the battery is charging. I have turned the air purifier off, and now the voltage is starting to climb, but not very fast. The power tool battery is still charging, drawing 45 watts. So now, because of this additional capacitor, I'm able to operate at a higher voltage, and I don't have to worry about it. The solar panel can only reach about 20 volts, something like that. So I really just need enough capacitors so that the solar panel could never overcharge the capacitors. The active balancer is still operating. You can see the yellow light right there. You can barely see it. It's still in operation, but it's not doing a lot of current right now. There's not much difference between the cells. You can see they're all pretty well balanced. About 2.5 volts, something like that. This is a different meter, and it's not super accurate, I guess, but it's good enough. On the mini bench power supply here, you can see 2.45 volts for the 7th capacitor that I added. The power tool battery is still charging, drawing about 45 watts. You can see it blinking here where my finger's pointing. I'm getting closer to a stable setup. I'm running at about 17.6 volts overall, if you add all the voltage together. And the setup is quite stable. It's charging a power tool battery directly off of solar. The only thing in the circuit that's helping the inverter is this supercapacitor bank here. I want a stable setup that I don't have to constantly monitor. In order to do that, I need to make sure I have enough supercapacitors in series so that the solar panel could never overcharge them. Also, I need very powerful balancing because these supercapacitors tend to go way out of balance and they're a little bit unpredictable. But with an active balancing board, a flying capacitor active balancing board, I no longer have to worry about the capacitors going out of balance. This balancer is very powerful and can actually dump 2 or 3 amps of current into an adjacent capacitor if necessary. I doubt there will ever be 2 or 3 amps of current actually flowing because once the capacitors are balanced, there's not enough differential to draw that much current through the active balancer. The active balancer puts more and more current into the adjacent capacitor when there's more voltage differential. As the active balancer balances the cells and they get closer and closer together, there is less and less differential and less current being used for balancing, so the effect tapers off. But that is not a problem for my application, and it appears that once the capacitors are balanced by this active balancer, they stay pretty well in balance. And if anything starts to happen or any of the capacitors go out of balance, this balancer can put it right in literally just a couple of minutes, maybe 5 minutes at the most. The disadvantage of other balancers that are active balancers is they only transfer current to the adjacent cells. And that's a big problem. This type of balancer here doesn't care where the imbalance is. It will balance all the cells, and it doesn't care if one cell is next door to another cell. Whichever cells are high, their current gets pulled out and put into the cells which are low. End of story. And to me, that's an ideal balancer. And the only other problem is turning the balancer on at the end of charge. In this case, I'm using capacitors, so I don't care. With a lithium-ion battery, of course, I would only want to turn the balancer on at the end of charge or near the end. The verdict on this flying capacitors balance board right here, an active balancing board, is very good. The capacitors are kept tightly in balance. They do not vary from each other much at all. I am extremely impressed at how well they work. I will probably never buy normal active balancers ever again. They are more expensive than other balancers I've purchased, but those other balancers are just going to sit on the shelf now, and I'm probably only going to use this type. I've tried running this setup with just the balancing that's included in the PCB here, and let me assure you that the balancing that's in this PCB is pretty much worthless compared to an active balancer. I don't even use the balancing circuits on this board. They are just not helpful at all. They don't work very well, and besides, they're not active balancers. They're just shunting the current across these small resistors that are on the board. Because these are capacitors and not lithium-ion cells, I want the balancing to be running all the time. That will keep the capacitors in check and keep them in balance, and that way I don't have to constantly monitor the capacitors and be concerned that one may go too high or go too low. I also installed another active balancer on a lithium-ion battery bank, a 3-cell, that had a problem with one cell discharging itself. And once again, the results were extremely good. It solved the problem, and I was extremely happy with the results. The normal active balancer I tried, which can only shunt current between adjacent cells, really just skewed the battery bank. It did not really balance the battery bank, so very disappointing. But as soon as I plugged the active balancer in, I was amazed at how quickly it balanced the battery bank and got it all sorted out. So can you use capacitors to balance capacitors? Actually, yes, you can. A flying capacitor balance board, active balance board, can easily and quickly balance a supercapacitor battery bank in no time at all. It works extremely well. To make the setup more interesting, I have added a voltmeter, which is measuring the entire capacitor bank, all 7 cells, and you can see the voltage there is slowly falling. Right now the sun is on the solar panels, striking them pretty good. This brings in an additional interesting concept. The solar panel has a maximum power point. So just because the voltage of the supercapacitor bank is falling does not necessarily mean it's going to be discharged. What it will do, ideally, is reach equilibrium with the maximum power point of the solar panel, or the point at which the solar panel wants to be pulled down to according to its internal resistance and according to the load that's placed upon it. So just because the supercapacitor bank is reducing in voltage does not mean it will be discharged. It could just be reaching a state of equilibrium. And it's awfully hard to tell whether it's that or there isn't enough power available and the bank is actually discharging. Right now the voltage has settled around 17.5 volts. I'm pulling about 45 watts from the AC side, and my air purifier is running, the battery is charging. It's working quite well. This battery is nearly charged though, so I suspect that it will stop pulling as much power as it nears the end of its charge. I'm referring to the Ryobi power tool battery here. What I will probably do next is wire this up a little better, put it in some kind of enclosure, and probably add an 8th cell, so I'll have 8 capacitors. and I'll probably use an 8S balancer and an 8S JST connector so I can monitor all 8 cells easily. And it's still hanging around 17.6 volts. Seems very stable. The voltage does fluctuate, but so does the load. Right now it's 42 watts. Sometimes it jumps up, sometimes it falls down. I'm going to go ahead and crank up the load and see if I can pull the voltage down and observe how it behaves. I turn the air purifier up on high. Now I'm pulling about 50 watts on the AC side, and the voltage is beginning to fall. And the setup is still running very stable. Now it's about 17.4 volts and it's hanging around there. So this is what I wanted, a very stable setup. It allows me to use all the power from the solar panel and have a small reserve in the capacitor bank. And I have less concern now about overcharging it. Previously, when I had 6 capacitors, that was not enough, and those got overcharged very quickly. It's still possible that could happen, but I believe with 8 capacitors, it should not be possible. I brought over a larger power tool battery to get the charger pulling more current. It's now pulling 68 watts on the AC side, and the supercapacitor voltage is falling pretty quickly. The active balancing board is still in operation, and you can see that all of the capacitors are pretty close, about 2.35 volts, which is excellent. It is several minutes into the test, and I'm actually running 3 items now. I'm running the power tool battery charger, I'm running a solder fumes extraction fan, and I'm running the air purifier. It's pulling about 57 watts, and the voltage of the capacitor bank is hanging around 16 volts. It jumps around a little bit. Seems to have stabilized somewhat. All of the capacitors are still somewhat in balance. They're maybe 40 millivolts away, which isn't too bad. Just to be clear, the purpose of this project is to run a pure sine inverter directly off a solar panel and run useful appliances. There are a lot of wires here and it's extremely hard to see what's going on, but the inverter, I assure you, is directly attached to a 100 watt solar panel. In parallel is a supercapacitor bank and various instruments for measuring the voltage and so forth. There is no battery, no charge controller, and I do believe this setup is going to be viable for me. I will be using it to run small appliances, and I will probably further develop it, and I may post additional videos as the updates come. Next task for me will be to add a 8-cell balance lead and add an 8th capacitor in circuit, and probably clean up the wires and find some way to put all this in a cabinet or a container so it's better looking. I'm going to end the video here or it will get incredibly long. I hope you enjoyed this video. Thanks for watching, and I'll see you later.